Hi everyone, welcoming to another episode of Mars, Geology of Mars and everything related to that. সো আজকের এপিসোডে আমি আসলে খুব শর্টে একটা ডেজা ভু নিয়ে কথা বলতে চাচ্ছি যে স্পিরিট অ্যান্ড পারসেভিয়ারেন্স রোভার তারা সিমিলার ফিচার্স অবজার্ভ করে বেশ কিছু টাইমের ব্যবধানে। So, back in 2005, the Spirit rover encountered unusual rocks rich in water, formed carbonate minerals mixed with magma-formed olivine. Now, half a world away, Perseverance is finding remarkably similar rocks. So, what does this all mean? So, on this episode of Mars, the Perseverance arrived in the margin carbonate terrain in early September of this year. It's a place that orbital spectrography said was rich in carbon minerals, like can be found along the margin of sailing lakes on Earth. It collected the first core sample of this stuff and moved on to second location by early October, which is where we'll pick up the story with this channel today. So for scaling this were close-up images from the arm-mounted Watson camera revealed that the surface with a notably rough and granular texture, the view with flicker vision nicely emphasized the gnarly texture which got my attention because it felt like I had seen it before on the other side of the planet. Here's a view at the same scale from the Spirit rover in the Columbia Hills of Goose Crater showing a carbonate-rich rock after brushing with the rock abrasion tool. It's got a remarkably similar texture, and the grains visible where dust has been brushed away have a similar range of angular to rounded shapes also seen in the rock, observed by Perseverance after it was abraded with the abrading bit on the drill. The rocks in both the locations also shows notably similar veins which likely resulted from mineral-rich fluids percolating through fractures and precipitating material that ultimately probably was harder and more resistant to erosion than the host rock, leaving it standing in relief in both locations. The rocks are rich in olivine, a silicate mineral formed from magma. This combination of carbonate and olivine is rare on Earth, but common on Mars and is a clue to the origin of the Martian carbonates, as the name suggests. So carbonates have carbon in them which typically comes from CO2 in the atmosphere. CO2 dissolved in water mixed with some calcium, magnesium or iron can precipitate carbonates that the Martian carbonates are almost entirely made with magnesium and iron, not calcium. The two elements that are found in abundance in olivine. Turns out that carbonic acid forms naturally from CO2 dissolved in water. Literally saltier water which can leach magnesium and iron from olivine and form carbonate minerals. This simply is a chemistry that's been pursued as a way to remove CO2 from Earth's atmosphere and sequester it in harmless carbonates. And this simple chemistry may explain the olivine carbonate rocks in Guzev and Jezero craters. It both contained volcanic rocks rich in olivine that was subsequently soaked in carbonated rock lakes when the atmosphere was thick with CO2, magnesium, and iron carbonates would have a natural consequence. So now two rovers have visited two different places on Mars that appear to tell the same story. And it feels like a deja vu, but it actually is an important addition to our evolving understanding of the history of water and climate and the surfacial geology of this planet. So until then, thank you very much and see you with some exciting content in next episode. So don't forget to like, subscribe and share the channel.